Welcome back to Sine and Cosine the functions, part 3. In this video, we're going to look at transformations of the graph. Now let's consider the transformation of the above graphs. To do this, recall that the rules of transformations you probably learned in your first college math class. The first one is that a vertical shift happens when you add a constant or subtract a constant from the function itself. So if you start with sine of x and you add a number, it will shift it up. And if you subtract a number, it will shift the function down. For horizontal shifts, remember that your plus c is on the inside of the f of x. So if you want to shift something to the left, you add a number on the inside of the function. And if you want to shift to the right, you subtract a constant from the inside of the function. If you want to reflect a function around the x-axis, that means you would go from some function looking like this. If you reflected about the x-axis, it would then look like a reflection vertically. So then it would be something like this, where your high points are now the low points and your low points are now the high points. You get the idea. X and negative y is a point on the graph of negative f of x. In other words, x stays the same, but y is multiplied by negative 1. So you can see how your y values, the high points, become the low points. They're swapped sign-wise. If you want to reflect about or around the y-axis, you substitute a negative into the function. So instead of having f of x, you would have the graph of f of negative x. But y stays the same. If you want vertical shrink or stretch, you take the graph f of x and multiply it by a scalar on the outside. This can be represented with a constant c multiplied to the outside of your function. If c is greater than 1, the graph will stretch vertically. And if c is between 0 and 1, meaning it's a decimal, f of x shrinks vertically. And your coordinate points will change from just xy to xcy, where you scale your y values. And finally, if you want something to horizontally stretch or shrink, you multiply your x coordinates by c inside your function. If c is greater than 1, the function shrinks horizontally. And if the scalar c is between 0 and 1, the graph stretches horizontally by a factor of 1 over c. If we look at the coordinate points for any given values, if you originally had the coordinate point xy, your x values become x divided by cy. So in other words, x gets divided by c, multiplied by 1 over c, but y stays the same. In this first example, we have the function sine of x minus 2, and we're asked to graph the following as we introduce the different transformations. So we're going to look at vertical transformations first. And so I first am going to just sketch key points on a standard sine function. I know that the maximum is at 1 and the minimum is at negative 1 for a period of sine. And I know that it will cross at 0, at pi, and at 2 pi. And I also know that if I break these up further, pi over 2 and 3 pi over 2 will give me those intermediate points. So I know that the maximum is going to be at pi over 2. Equilibrium is at pi, and I know that the minimum happens at 3 pi over 2, so I'll put a dot there, and then it goes back up to the equilibrium at 2 pi. If I make a dotted line that represents this curve, I will then be able to use it as a reference. All my points are getting shifted down by 2 units. So what was a 0 is now a -2. What was a 1 is now a -1. What was a 0 is now a -2. What was a -1 is now a -3. And what was a 0 is a -2. And now we can sketch the actual graph that looks something like this. And of course, this would continue moving forward to the right and to the left, but I've graphed at least one period of it. So I think you get the idea. If I wanted to figure out what these coordinate points were, notice that I just take the y value, x value stays the same, y value is subtracted by 2. In our last example, we have vertical flip, and it's given to be the function g of x equals -sine of x. First, I will label my axes. And what I would recommend is if you are in a class with an instructor you're not familiar with, you should always ask how many points they want graphed if they're not giving you a calculator. The maximum is at 1, the minimum is at -1, and I have equilibrium intersections with the x-axis at 0, pi, and 2 pi. If I sketch this graph, it will be something like this. And of course it continues on to the left and to the right of this one period that we graph, but usually one period is sufficient to show that you know what you're talking about. Now I'm going to flip it over because remember the negative on the outside says the function is reflected about the x-axis. So wherever the function was positive, the y's are now changed to negatives. So the reflected curve will be a flip. If you think of it as rotating about these equilibrium points, you can see how it could be flipped over at these dots. And now your negatives are positives and your positives are negatives.